So this is your questions number 3. You are given a scenario here where a student push a block with a mass of 1.5 kilogram against a horizontal spring. So on the first case, these students over here, or this hand over here, was push this box towards the wall, which is compressing the spring, where the value of the compressions is equal to 0.125 meter. So your X maximum is equal to 0.125 meter. And then when it is released, it is found that this block over here was travel horizontally surface and then up in the incline. So at this point, it is the block was positioned at 1 point of height, which is in this question you were asked to find the height of the new positions of the block. So by neglecting the frictions of this surface nor on this surface, you were asked to find the block maximum height, which is the YF over here, if the spring constant K is equal to 575 Newton per meter. So before we continue with the solutions of this question, you need to understand, or you need to determine what is the value which equal to 0 in each of the positions of the blocks. So at this point, before the student push the block, you need to know that the velocity over here, or the initial velocity of the block, is equal to 0. And also with the y, which is the height of the block, is also equal to 0, since these blocks over here was in the positions of horizontals. While when the block at these positions, we assume that this block stop at one point, so the final velocity is also equal to 0. So this is the sketching of the questions. I already take out everything for you: the mass of the block, the stretch distance, and the value of the spring constants. So you have to calculate this value over here, which is the maximum height. So to start this one, I have to use the conservations of mechanical energy, where it is stated that the conservations of mechanical energy state that when you have a spring in your system, your kinetic energy plus with the potential energy gravity plus with the potential energy spring initial is equal to constant, where everything in here is supposed to be also exists in here. So you also have kinetic energy plus potential energy gravity plus potential energy spring on the final positions. So in these questions, this is the first positions of your block, where the first position state that before it is pushed, the value of velocity is equal to 0, and the value of y initial is also equal to 0, because at this point the students is not yet push the block, and the block is also positions at the horizontal point. Now this is your initial position, while your final positions is at this point. So this is your final position, where the block is positions at y is equal to f. So your y final is equal to some value, which is x something, and then we assume that at this point the block is stopped a moment, so your final velocity is equal to 0. So by knowing the value which equal to 0 in each positions, I know that from the equations, sum of the value is also equal to 0. So this is the initials positions where I know that the kinetic energy is equal to 0 due to the velocity is equal to 0. So this part is equal to 0. And then the potential energy, the gravitational potential energy is also equal to 0 due to the height is equal to 0. So this is also equal to 0. Then since this one is attached with the spring, where the spring have their own x or their own amplitude, so the potential energy spring is equal to 0. So this is left with the value of half kx squared. I think you know these equations because you already introduced it in SHM. So this is the first part of the positions. Now, move to the final positions of the block. I know that the final velocity is also equal to 0. So the kinetic energy is here is also equal to 0 due to the final velocity is equal to 0. But then the potential energy is not equal to 0 because we do have the final positions of the block which in one point of height. So my potential energy is equal to 0. Then I know that the gravitational potential energy, the equations of gravitational potential energy is mgh, which in this question your h is also equal to your final height. And then the spring constant over here, if you realize the block, when it reached the final position, it's not attached with the spring anymore. So the spring is not, the potential spring here at the final position is not really exist. With the x is equal to 0, so this one is equal to 0. Then this is your final positions. So by rearranging these equations, you're supposed to get the value of final positions. So by rearranging everything, you will get your equations is equal to like this. So you do have your spring constant, you do have your stretch spring, you do have your mass and your gravitational acceleration. So substitute every single information that you were given. Sorry. You will supposed to get the answer is equal to 0.306 meter. So the new positions of the block, the height of the block now is equal to 0.306 meter. And but then the value of y, which is the height, is not equal to 0, which you need to find on in these questions.